So in this lecture we will study about a term that is called as kernel trick. Okay. So what is called as a kernel trick? That is kernel trick. Okay. So what is called as a kernel trick? So kernel trick means to represent a data in a high dimensional space. Okay, to separate them very easily. Okay, for example, when a data pattern has a linearity, okay, suppose this is a group, circle group and cross group. Okay, so this pattern, okay, has a hard margin. Okay, hard margin. So what is a hard margin? Hard margin means we are totally setting a margin which is a hard rule for this type of groups. Means they will be separated by this distance only. Okay, so this is a hard margin. Okay, and suppose this is called as linear representation of data. Okay, when we are going for non-linear, okay, this is called as linear representation. Okay, and in the non-linear representation, okay, so in the non-linear representation of the data, okay, the data may be in they may be in any form. Okay, so for them, for example, if this is a line, okay, and a group is there like this, okay, then cross, okay, then a group is there. So from this you can see that the points of the cross, okay, are in the group of circles. Okay, and if we will set a hard margin here, then it will be not suited to this problem. Okay, so we will add a soft margin here. Okay, we will add a soft margin here. So in the soft margin, what we are doing, we are just changing the dimensions from 1D to 2D. That is called as the kernel trick. Okay, by which the dimensions are changed, and this can be very easily represented in a 2D form, and we can classify the circles from the crosses. Okay, so there should be a soft margin between them, so that we can because it has a majority here. Okay, so this cross may be in this group. Okay, so we will go up to here. Okay, and this is a group. Getting? So what our kernel trick says, we have to increase the dimensions to represent the patterns to clearly classify them. Okay, so if we are representing a thing R in one dimension, then it will be converted to more dimensions, that will be 2D, by using a function psi. Okay, getting? Suppose for example psi a comma b, these are the inputs. Okay, psi, okay, function, okay, a comma b comma a square plus b square. Okay, so this is a these are two parameters which will be changed to 2D by this a square plus b square. If we are represented a and b in a square plus b square form in a 2 dimension, then this problem may be solved by using this. We can classify the circles from the crosses. Okay, so now I will represent a problem, okay, which can solve this kernel trick. Okay. So basically, for example, a graph is there, okay, and a square group is there. This is x and this is y, and two circles are there, okay. And if we are separating, so what we will simply do, we will draw a line like this, okay, getting. And if we represent this 2D in 3D space, then we can represent this, okay, by a plane that is x, y and z part. So here we can represent this as a plane, okay. So here we can draw the circles, okay. So this is a plane and this is a plane, okay. So here we can clearly see that the points are in the upper part and the points are in the down part. So here it is clearly visible, clearly separable. But in 2D we are unable to define them. So in 3D we can represent it in a better manner. Okay. So the kernel trick says that we have to increase the dimensions to separate the things. Okay. So basically we will solve a problem by which we can understand the rules of kernel trick. Okay. So suppose a 2D, suppose a 2D graph is there, okay, and points are there. This is 3, 0. This is x and this is y. This is, and a square is there 1, 2, and a square is there 2, 1. Okay, and this is 0, 3. This is a circle, and these are squares and these are circles. Okay. So basically we will apply some operation here, okay, by using the psi of what I have told. Okay. So if we draw a graph x plus y, x star y and x square like this, okay, and we will do some operation here, okay, for these points, 3, 0, okay, for these points, with 0, 3, 0, 2, 2, 1, 3, 0. So if we will do x plus y, x star y, x square operation here, okay, you can see that they will form something like this. The values are 0, 0, 1, 4, 9. Okay. So here we can see that we can generate a pattern or of the results. Okay, we can generate the patterns of the results. Okay. So here we can see that if we are doing a star operation, then the results are 0 or 0, okay, and or 2, 2. Getting? So these are the points 0, 2, 2, 1, 0, 2 and 2, 1, 2, 1, and for this 0, 3, 3, 0. Okay. So these are the points which are in the same group. So from this pattern we can see that this 0 will be in same group and this 2 will be in same group. So we can represent this, okay, this by applying, we can represent in applying a rule that is x star y in the 3 dimension. Okay. So how to represent this in 3 dimension? So in 3 dimension we can represent psi x comma y is equal to x comma y comma xy. Okay, this is the operation we are doing to represent the 2D parameters in 3D. Okay, so here we can see that 0, 3, that will be 0, 3, 0, and 1, 2, that will be 1, 2, 2, then 2, 1, that will be 2, 1, 2, then 3, 0, that will be 3, 0, 0. Okay, so these are the points you are basically 3. If 0, 3 is written, then that can be represented as 0, 3 is 0, because x into y is 0, then 1, 2, 1, 2, 2 into 1, 2, 2, 1, then 2, 3, 0, then 3, 0, 3 into 0, 0. So this pattern can be represented, in, we have to represent this in 3D. Okay, so basically you see this thing. Okay, this can be represented in 3D like this. Okay, so this is x, this is y, and this is z. So here 2 points are there, that is 1, 2, 2, then 2, 1, 2. Okay, then here a point is there, circle points are there, 0, 3, 0, 3, 0, 0. Okay, so here you can see that the points in this plane, okay, the points in this plane, okay, they are totally separable and clearly visible. Okay, so this function separate them from 2D to 3D. So this trick is called as the kernel trick. Okay, by which we can clearly separate 2D space into 3D space, or 1D space into 2D space, or from the dimension D, from a dimension D, okay, to a high dimension, okay, by using a function psi. So that dimension have some x, y, and the high dimension have some operation x, y, some OPR. Okay, some operation x, y, OPR operation. Getting? So this is a nice problem, okay, which can be solved using the kernel trick by increasing the dimensions. So thank you.